Okay, so what happens if you change the number of hydrogens? So, or add hydrogens. So unfortunately, again, this is a common thing. So we have to talk about it. Right now, it's not going to be so bad, but after we do acids, you're going to be annoyed. And I'm going to try to give you tricks to not be annoyed, but this is annoying, okay? So you can add hydrogen to a polyatomic ion. So sulfate is on your periodic table. I don't know why I use green, sorry. Okay? The last changes we made to the ions were adding oxygen, or changing the number of oxygens, taking them away, whatever. This one, so now the new polyatomic ion is hydrogen sulfate together. So eventually, when we do examples with the crisscross rule, your teacher in grade 10 would have told you about using brackets, right? So I usually tell students, even if, let's say you crisscross and it's ones or something like that, and you don't technically need the brackets, if you always want to put brackets around polyatomic ions, do it, okay? So like this, sulfate always has S and 4 O's, okay? You can keep it in brackets. So technically, when you put a hydrogen with a sulfate, now that is going to be in the brackets, okay? I know, weird. The other thing with hydrogen, hydrogen has a powerful positive charge, I'm going to call it, okay? So in a second, we're gonna review or discuss acids. Later on, we're going to do a whole section about acids. And so maybe you've heard of the pH scale. Maybe you have a pool or a hot tub, you have those pH strips. pH literally stands for the power of the hydrogen ion. So hydrogen is a powerful ion that creates a solution with a low pH or acidity. In biology, if you're a biologist, you're going to talk about pumping ions across cell membranes. And one of the ions that is important in how we make energy for our muscles and everything is pumping protons. So we literally have a special name for that hydrogen ion. It's so powerful, okay? So hydrogen has a very powerful positive charge because it has no neutrons. It's lost its electron. All it is a proton. That's powerful, okay? So when you put hydrogen with a polyatomic ion, then the charge is going to change. So logically then, if the charge on the ion is +1, then the charge on this is going to change by +1. So -2 +1 is -1, okay? We're going to see this again when we do acids. You're going to see it in grade 12. So as annoying as this is, unfortunately, it's a common thing. The good news is, take a look at your back of your periodic table for a second. We have, if you look, there is carbonate, yes? And then, if you look at the -1 charge box, there is one not the first one, that's acetate. The second one says HCO3, -1. That's hydrogen carbonate. So, hydrogen carbonate is actually commonly called bicarbonate. So it's a very, very common ion that has hydrogen attached. So this gives you a clue. If you look at carbonate, its charge is -2. When you look at hydrogen carbonate, its charge is -1. So if you forget this, the back of the periodic table will help you, okay? So this is technically a polyatomic ion. This doesn't exist by itself. So you would have to have something else. Let's do... Again, it's not like every single question can be one of these, right? Okay, so try not to freak yourself out. So when you have the polyatomic ion, it's still going to have a charge, and we want it to be zero, right? We want it to make a compound. It has to cross with something else. So it would have to have a metal because they are positive, and then this part will be negative, right? Negative and positive opposites attract. It's the whole thing of chemistry. So you have to have something else with it. So this looks weird, calcium and then hydrogen sulfate. So hopefully that's, you know, the trigger for your brain. Oh yeah, these go together, okay? So then you would do calcium, which has a charge of 2. Again, even though we haven't done anything yet, we haven't crisscrossed, if you want to always think about polyatomic ions inside of a bracket traveling together as a package, I recommend that you do that, okay? So now this 2 crosses all the way across. Okay? So this becomes the new polyatomic ion. Okay, so we're going to do more examples of these after we do acids, and you'll see why in a minute. So let's just do some review of polyatomic. So we'll do barium sulfate, calcium nitrate, and iron 2 nitrate. So again, they are similar to ionic compounds. You're going to follow those rules. So you are going to put the positive on the left. Usually it's a metal. The only polyatomic ion that is positive is NH4. Do you need to memorize that? Or is it on your periodic table? Back here, okay? It's on here. You don't need to memorize any weird ones, okay? The negative species goes on the right. You can use, if you have a transition metal, then you would have to use stock or Latin, whatever you prefer, and then reduce the subscripts, crisscross rule. So they're basically ionic compounds, except you have that weird polyatomic structure, okay? So again, one of the more common forms of the polyatomic ion is to have oxygen. So when you look at this and you look at the end, you're like, oh yeah, that's sulfurs with an oxygen. That's going to be ATE. Okay, so hopefully the more practice you do, then the triggers will be there for you. Let's say you get this and this hurts your brain, you don't like it, put brackets in, okay? Let's say you're not sure. Take a look at the back of the periodic table. Is SO4 on there? Yes, it is. Okay, so take your time, always check, don't rush. So this is just an alkali earth metal, 56. So no Roman numerals or anything. Whether you use pH or F, I don't care, it doesn't matter. Okay, so barium sulfate. So barium sulfide is just BAS, okay? Is this tricky? Yes. Is this annoying? Possibly. The more practice you do, that's why I gave you worksheets. There are zillions of questions in the textbook. You literally would have learned this in grade 10. We're reviewing it because it's so important, okay? So hopefully, like I said, you're going to see this oxygen. At the end here, you're going to think in your head, oh, that's sulfur 8 oxygen. Oh, it's sulfate. Even though that's a cheesy analogy, you're going to hear my brain. It's seared in your, you're going to hear my voice. It's seared in your brain, okay? So when you go down here, when there are words, look at the end. Oh, ATE. Okay, 8 oxygen. Let's go look. Is it back here? Yes, it sure is. Now, the good news is nitrate, for example, is a very common polyatomic ion. I've even had students be mad at me. Because Todd, I have nitrate memorized. And I'm like, oh, excellent. And they're like, no, it's your fault. I'm like, well, okay. But so sometimes you'll find that you're going to recognize it, hopefully, okay? So calcium is, just like barium is an alkali earth metal. It's got a 2. Nitrate. You go at the back, take a look. There it is, nitrate. In the -1 charge spot, okay? And then you crisscross. So let's say you are the kind of person who wants to memorize or you want it to be in your brain. You can certainly make cue cards or whatever out of this. You can write it over and over again. That's a way to memorize things. You don't need to, but if you think that that's going to help you feel secure and be like, I got this, confident in what you know, then that can be a way that you study too. Okay, it's up to you. So remember, it crosses all the way across. Okay, so here you must have brackets. Up here, we didn't have to because they're both 2s, they cancel out. Okay, so like I said, where sometimes it is required to have the brackets. So if that helps you, always put brackets. I don't care. So then this one, so we already know what nitrate is. Okay, so this 2 came from the iron. Because nitrate is 1, we don't have to worry, was it reduced or whatever. Like I said, that's not really a common thing. It's really usually rare. So now you have a choice. If you like to use Roman numerals, then go ahead. If you would prefer to use Latin names, then you have to go check. So iron is iron 2 or iron 3. So this is the lower charge, so it's ferrous. I don't expect you to use this. If you like this, that's fine, okay? In worksheet number 1 and worksheet number 2, I provide both answers. But that's not an expectation. You don't have to write both. I just wrote them in there so you could check your work, okay? Like no number here. It's 1, so you can write the 1, but you don't have to. Like the charge on nitrate is 1, so when you cross it, like this 2 comes over here, but then this is just 1. It is in the box that says -1 charge. That's why. Okay? Okay. So let's make some acids. Now, again, depending on your grade 10 teacher, you might have talked a little bit about this. When you are expected to name something as an acid, if you do the textbook work, they're going to use AQ as the subscript. I think on the worksheet, it says write the formula for the acid, okay, in the question. What I'm going to do, I'll write both. So I'll put AQ like this, and then in brackets, I'm going to write acid, okay, so that you know to name it as an acid. So I'll let you know that. But I believe in the textbook, it might just use the AQ there. Acids are water-loving. They're always dissolved in water. That's what that means. Okay. I'm going to skip this for a second. And the reason we have to say if I want you to name it as an acid is because it's actually basically an ionic compound with hydrogen. So if you're a highlighter, this is a good thing to remember for the rest of your chemistry lives, okay? Acids always have hydrogen. Remember I said pH, the power of the hydrogen atom. We're going to talk a little bit about bases. Bases can be a little bit different, but acids must have the hydrogen. So then an acid is just crisscrossed with hydrogen. So hydrochloric acid is HCl because hydrogen is 1 and so is chlorine. You've just crisscrossed. When you make what we call an oxyacid, which is a hydrogen plus something with oxygen, you're going to use the polyatomic ion, okay? If you want to put a plus there so it's more obvious that you're going to crisscross. So you take the polyatomic ion, and again, sometimes it's called a parent, okay? So what's on the periodic table we call the parent form. So nitrate is NO3, so it makes the parent acid HNO3, okay? So nitric acid, you've just crisscrossed, they're both ones. Same thing with polyatomic ions. If you would prefer to always keep it in a bracket, that's totally fine, okay? It's really up to you. And hydrogen always has a charge of 1, so really there's never a need for brackets because you cross over the 1, you know, but you can always put them in there if you want. The big thing with naming these, when it says acid, you don't want to write hydrogen nitrate. You want to call it nitric acid. Okay, so that's why I'll literally use the word acid so that it's really obvious to you. So these acids, these parent acids, all come from crisscrossing with the polyatomic ion. So this is chlorate. Do you have to memorize chlorate? No, it's on here, okay? Then you crisscross. Carbonic acid. You crisscross with the carbonate. Sulfuric. You're just crisscrossing. So again, why do things like this matter? What we're going to do later is we're going to talk about the difference between the hydrogens and how that affects the math with acids. That's what we're moving towards. Phosphoric acid is a very, very, very strong acid. Sulfuric acid is battery acid, or sometimes if you've heard of people throwing acid on someone and like burning their skin right away. Usually it's sulfuric, which is not, it's not easy to get. Like you wouldn't go to the store and be like, please give me some sulfuric acid. It's not a thing. Carbonic acid is the acid in pop. So, maybe you watched a video, you heard of, like, if you put a tooth falls out, and you put it in Coke, by the next day that tooth will have dissolved. So yeah, like, acids, they say, oh, acids aren't good for your pop's not good for your teeth. They're not lying, okay? So it's also the acid that's produced by carbon dioxide, too much carbon dioxide in the atmosphere, in water, making the oceans acidic. Chloric acid. So we're going to talk about changing the number of oxygens. Perchloric acid is the strongest acid. As in all my years as a teacher, student, whatever, I've never used it. Okay, so generally speaking, these oxy acids are a little bit more reactive. Okay, so we're going to do the same thing-ish. So the good news, some good news for you, okay? Per is one more oxygen. That's the same. But then OUS is one less. That is not the same. The other one, it was ITE, right? But then this one is the same-ish. Hypo-us is two less. And then this is the parent form. So hydrogen plus the polyatomic ion. PT means periodic table chart, okay? So then, again, go back to your conjugation sheet, and you can do the acid part. So nitric's already done for you. If you want to go to chloric and try that one. Again, there's not that many choices, right? So it's not like every single question, I can ask you this or whatever. I'm not a trickster. Okay, so let's take a look. Again, it's kind of tiny, but really what you want to make sure you do is crisscross. So hydrogen always has a 1, and then when you crisscross with the polyatomic ion, there's no charge left up here, right? Okay, because you've crisscrossed. And then similar to when you did the form above, so sulfuric acid starts at 4, so persulfate is then 5. Same thing with phosphoric. All the other ones, their ATE form is 3, okay? And remember, if I wanted you to name this like an acid, it's going to say beside it, acid, okay? Okay. So let's take a minute to just think about this. So again, I'm really going to try to emphasize acid, 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 okay? because this can sometimes mess people up. So acids always have to have a hydrogen, but we did just talk about what happens when you put hydrogen with a polyatomic ion. But the thing with that is when you have an acid and you put it with hydrogen, that's the crisscross, okay? So phosphoric acid, for example, is H plus crisscrossed with PO4 3 negative, no charge, right? When you make hydrogen phosphate, then it still has a charge. So you would never have hydrogen phosphate by itself and still have a charge like this, okay? So there has to be a metal or something with it, okay? So it's always going to be something out front. Metal, that's positive. Hydrogen phosphate. If it's going to be an acid, it'll either say phosphoric acid and you have to write the name, or it'll say H3PO4 acid and you have to write the name, okay? So this, when you see that acid, that's your clue. Oh yes, I got this, okay? Okay, so the next slide says less easy examples. You might say to yourself, Ms. Todd, you should just call those difficult. No, they're less easy. We got this. They're also not like the second one for sure is like so rare and it's really the most difficult kind, okay? But I just in case you see it, we're going to do it together, okay? All right, so this one is not so bad. It's got the HPO4 in brackets. So hopefully you're like, oh yeah, polyatomic ion, I got this. This is phosphate. And then there's a hydrogen. And this is just sodium metal, no big deal. So when you have that O, then that's your trigger. Oh yeah, it's not IDE. Let's go look on the back of the periodic table. So this is phosphate. But there's also a hydrogen attached to it. And then Na is sodium. Okay, so there's the metal, right? So I want, number 2, I want you to write beside it rare. Okay, because this is, what's the difference? How do we show the difference between this and this, okay? So what's happened here, we have sodium, and we have hydrogen and phosphate, right? But how many hydrogens do we have? 2. So what we're going to write, if you like colors, pick a different color. So because phosphate has a charge of -3, you can keep going and add more and more hydrogens to it. But again, that kind of question is rare, rare, rare. But just in case you see a metal and a polyatomic ion and it says dihydrogen in there, then I just wanted you to see it. This one is rare, but not so bad, okay? So this is sodium again, and hydrogen. And this almost looks like phosphate. So this is where now we're mixing the oxygens too. So if you have 2 less oxygens, it's hypoite. Again, can every question be like that? No, of course not. Okay, so this last one I included on here because, again, I give you on the periodic table, because it is so common, I give you kind of a benchmark, right? So that one it is on there, okay? So that can help you remember, oh yeah, if there's an H beside the polyatomic ion, to put hydrogen in there, because it's on the back here, hydrogen carbonate, okay? So you have a choice. This is tin. It is 4. Which, if you like Latin names, you can call it stannic. I don't care.